Last class about abstract classes you studied. Next concept, interfaces. Note. Next concept, interfaces. Abstraction principle, if you want to implement, two concepts are there. Abstract class, interface. So interfaces. Next note. An interface is a collection of public static final variables and public abstract methods. An interface is a collection of public static final variables and public abstract methods. An interface is a collection of public static final variables and public abstract methods. You already studied about public, static, final, variables, methods, abstract methods. These are all completed already. Okay. What is interface? An interface is a collection of public static final variables and public abstract methods. Public static final variables, public abstract methods. You studied class. What is class? Collection of variables and methods. What is interface? Collection of public static final variables and public abstract methods. Okay. Now, public completed, static completed, final completed, abstract also completed. Now, next point. In interface, all variables are implicitly public static final, and all methods are implicitly public abstract. In interface, all variables are implicitly public static final, and all methods are implicitly public abstract. In interface, all variables are implicitly public static final, and all methods are implicitly public abstract. So by default public static final, by default public abstract. In interface, all variables are implicitly public static final, and all methods are implicitly public abstract. Clear? Now, I'll ask one question, give me answer. We've seen these 2 points. You can give answer it if possible. Suppose interface A, here integer x equal to 10. Is it instance variable or class variable or local variable? Think yourself, already 2 points now. For creating class keyword we use. For creating interface keyword we use. Just now I given 2 points. Now with this knowledge, you can give answer. Is it instance variable or class variable or local variable? Which variable? Class variable. But class variable means static record, but very static. Implicitly static. Static, no need to write. Implicitly static. Say, in interface, all variables are implicitly public static final, and all methods are implicitly public abstract. In interface, all variables are implicitly public static final, and all methods are implicitly public abstract. Okay. Now, int x equal to 10. If I write int x equal to 10, it is implicitly public, implicitly static, implicitly final. Okay. Now, here I'll write void show. Is it concrete method or abstract method? Is it concrete method or abstract method? Abstract method. Is it valid? Valid or not valid? Valid. But already you studied abstract method must be declared with abstract keyword in Java. But how it is valid? Implicitly abstract. Implicitly abstract. Okay. Now, already you studied if the class contains an abstract method or if the interface contains an abstract method, then if the class contains an abstract method, then the class must be declared with abstract keyword. Interface contains abstract method, but here abstract keyword not required. Reason, implicitly abstract. That point also note on. Interface itself implicitly abstract. Interface itself implicitly abstract. Interface itself implicitly abstract. See, if you write like this, abstract interface A. Abstract interface A. Here, public static final integer x equal to 10. Public abstract void show. Now, whatever we written like this, it is equal to like this. See, here I written int x equal to 10. By default public static final. I written void show. By default public abstract. I written interface. By default abstract interface. So here implicitly public static final, here implicitly public abstract, here only abstract, implicitly present. All variables are implicitly public static final. So like this. All methods are public abstract. Every interface abstract interface. Like this. Write this example. Example. Is it over? Here, for you appears like this. For compiler appears like this. Okay. For you appears like this. For compiler appears like this. So if I write like this also, you have to assume like this. Then you will understand subject. Then only you can understand subject. So even if I write like that, you assume like this. Then only you can understand subject. Okay. Now, this variable, can I access outside the package? This variable, can I access outside the package? Yes or no? You studied access modifiers. How many access modifiers? 4. What are those? Public, private, protected, no name, nothing but default. Now, what is the scope of default? Package. What is the scope of private? Within the class. What is scope of protected? Package and subclass. Subclass can be outside the package also. What is scope of public? No restriction. Anywhere you can access. No restriction. Okay. Now, my question is, this variable, can I access outside the package? Yes or no? Yes. What is scope of this one? What is access modifier? Public. But where is public? Implicitly public. No restriction. Anywhere you can access. Okay. Is it instance variable or class variable or local variable? Class variable. But class variable means static record. No? Where is static? Implicitly static. Okay. No need to write. Can we change the value of x? No. Why? Final. But where is final? Implicitly final. Okay. Is it valid abstract method or invalid abstract method? Valid. But abstract keyword required. No? Where is abstract keyword? Implicitly abstract. Okay. Is it concrete interface or abstract interface? Abstract interface. But where is abstract? Implicitly abstract. So if I write like this also, it is abstract interface. If I write like this, it is public static final integer. If I write like this, public abstract. Okay. Now, next point. Interfaces cannot be instantiated. Interfaces cannot be instantiated. Interfaces cannot be instantiated. Instantiation means object creation. Okay. Interface can be inherited into a class by using implements keyword. Interface can also be inherited in another interface by using extends keyword. Interface can be inherited into a class by using implements keyword. Interface can also be inherited in another interface by using extends keyword. Interface can be inherited into a class by using implements keyword. Interface can also be inherited in another interface by using extends keyword. Is it over? Interface can be inherited into a class by using implements keyword. Interface can also be inherited in another interface by using extends keyword. See, can we create object to this interface? No. Can we inherit into a class? Yes. Which keyword? Implements keyword. Now, you studied abstract class. Whenever abstract class is inherited, then all abstract methods must be overridden, or subclass must be declared with abstract keyword. Otherwise, compile time error occurs. See, up to exception handling, you have to remember subset. If you forget further, you cannot understand. Up to exception handling, you are learning language. Language, if you are perfect, you can develop application. But language only if you forget, language if you remember, you can develop application. Language only if you forget, further you cannot do anything. Up to exception handling is called language. If you are familiar with language, then only application development is possible. That's what up to exception handling, you have to remember subject. Compulsory. Okay. Here, same concept, here also applicable. Note down. Whenever interface is inherited, then all abstract methods of whenever interface is inherited, then all abstract methods of an interface must be overridden in a subclass, or subclass must be declared with abstract keyword. Otherwise, compile time error occurs. Whenever interface is inherited, then all abstract methods of an interface must be overridden in a subclass. A subclass must be declared with abstract keyword. Otherwise, compile time error occurs. Whenever interface is inherited, then all abstract methods of an interface must be overridden in a subclass. The subclass must be declared with abstract keyword. Otherwise, compile time error occurs. Whenever interface is inherited, then all abstract methods of an interface must be overridden in a subclass, or subclass must be declared with abstract keyword. Otherwise, compile time error occurs. See, here, this interface inherited in B class. Inherited in B class. Whenever interface is inherited, then all abstract methods of an interface must be overridden. This show method must be overridden in B class. Must be overridden. Or subclass must be declared with abstract keyword. Otherwise, compile time error occurs. So either override this method here or declares abstract here. Any one we have to do. Otherwise, compile time error. See, file, save. If I compile, we'll get the error. See, Java C, B.Java. Now error. See, B is not abstract and does not override abstract method show in A. So what system saying? either write this one abstract or override this one. Suppose. Now what system saying is write abstract, it is saying. See, B is not abstract. It is not declared with abstract because it is not overridden. Not overridden means it is inverted here. Here also abstract will be there. Abstract method. Then if the class contains an abstract method, then the class must be declared with abstract keyword. Like that. Here abstract required. Will it compile? Yes, it will compile. File, save. It will compile. But can we create object to B class? Can we create? No. Again, you have to invert. At last, you have to override this. Okay. Instead of writing abstract, override this one here. Okay. Void show. System.out.println show method. Now I'll ask question, give me answer. This code, will it compile or not compile? Each and every line you check it and give me answer. Each and every line you observe. Will it compile or not? Give answer. If I compile, will it compile or not? Each and every line, each and every character you observe. Then give answer. Each and every word you observe. Each and every word. Then give answer. This code snippet, if I compile, will it compile or not? Compiles? Give me answers. No one is giving answer. Not compiles. Okay. Next. Your answer can be right or wrong. Compiles or not compiles, you select first. Online students. Compiles, not compiles, compiles, not compiles. Okay. Next. Your answers. Okay. How many people answer compiles? How many people answer compiles? Okay. Online students. How many people answer not compiles? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Online students. Those who given not compiles, why it will not compile? Okay. Next. Those who given not compiles. Give me answer. One person given answer. Other people. Why you selected not compiles? Those who 10 plus members given answer. Reason I want. Reason. One person given reason. Why it will not compile? Given reason. Next. Blindly if you select, no use. With reason. Why it will not compile? Online student, those who given answer not compiles, why it will not compile? 10 plus students selected answer, not compiles. One person given answer. This program, it will not compile. One error is there, he given right answer. That answer all people not understood also. I know about that. Whatever he given, you didn't understand also. I know about that. You already studied overriding rules. Year. Year which access modifier? Public. Year which access modifier is there? No name. Okay. In superclass public is there. Subclass what is required while overriding? Public only required. It is more restrictive access modifier. Overriding rules you studied, no? Overriding rules. In method overriding, overriding method can have same access modifier or less restrictive access modifier. Must not be more restrictive access modifier. Now, here which access modifier present? Public. It is public or no name? Public. By default public there. Here what is there? No name. In superclass public is there. In subclass which access modifier valid? Public only valid. In superclass protected is there. Subclass what are valid? Protected valid. Public valid. In superclass default is there. Default valid. Protected valid. Public valid. Superclass private is there. All are valid. Methods cannot be overridden. Private method cannot be overridden. That is recently you studied. No? Recently you studied. Here what is there? Here which access modifier present? Public. But where is public? Implicitly public. Here which access modifier present? No name. Is it valid? No. Error comes. File, save. If I compile, it will not compile. See, p.java line number 8. Error. Show in B cannot implement show in A. Attempting to assign weaker access privileges was public. So, here public is there. It is weaker. It is stronger. Here stronger required. Here weaker required. Reverse is there. So, here we are write public. Then it will compile. Now, here which access modifier present? Here which is present? Public, valid. File, save. It will compile. Okay. Now, integer y equal to 20. This is which variable? Instance variable or class variable or local variable? It is instance variable. Here one more method I'll write. Here you observe. Here x, here y, show, print. Now x variable belongs to A interface or B class? A interface. Y variable belongs to B class. Show method belongs to A interface or B class? A interface. A interface show method overridden in B class. A interface show method overridden in B class. Okay. Print method belongs to B class. Now, public static void main string args. Here, A OB equal to new A. Is this line is valid or not valid? Valid or not valid? Why it is not valid? Interfaces cannot be instantiated. So it is not valid. Now, BOB equal to NeoB. Is it valid? Valid, no? No. System dot out dot println OB dot X. Is it valid? Yes or no? System dot out dot println OB dot Y. OB dot show. OB dot print. Compilation, execution. Okay. Write this example. Is it over? Now, I'll ask questions, give me answer. First one, A OB1 equal to new A. Is it valid or not valid? Why it not valid? Interfaces cannot be instantiated. P OB2 equal to new B. Is it valid? System dot out dot println OB2 dot X. Is it valid? System dot out dot println OB2 dot Y. Is it valid? OB2 dot show. Is it valid? OB2 dot print. Is it valid? Valid. Third one. A OB3 equal to new B. Is it valid? Valid or not valid? Valid. System dot out dot println OB3 dot X. Valid or not valid? Valid. System dot out dot println OB3 dot Y. Not valid. OB3 dot show. Valid. OB3 dot print. Not valid. B OB4 equal to new A. Not valid. Okay. Now it is not valid. Order. Is it completed? I'll ask some more questions. Give me answer. Is it over? No. System dot out dot println X. This X, like this I'm printing. Valid or not valid? Valid or not valid? That is which type of variable? Class variable. Class variable. No. Can I call it directly? Yes. Here, when we can use directly? if it is present in the same class, but it is present in A interface, but I'm writing in B class. Valid because inheritance relationship is there. Inherited. It is valid. Now, can I write system.out.println A.x? Valid. System.out.println B.x? Also valid. Inherited. That is like that it will treat. So X also valid, A.x also valid, B.x also valid. See. Compilation. Okay. Suppose if I remove this line, is it valid? Valid? Not valid. Is it valid? It is valid. This one, not valid. Okay. If I remove implements, then X you cannot access directly. A.x valid, but B.x also not valid. So only one line valid. See, 2 errors comes. See, 2 errors. X directly not possible. B.x not possible because between A and B no relation. Okay. One more thing. Dot class also generated 2 dot class files. Interface also generated. Interface also dot class generated. B also dot class generated. This is class variable you can access, but other things not possible. Now, next node on. Note. Java compiler generates dot class file for every class and every interface in a source file. Java compiler generates dot class file for every class and every interface in a source file. Java compiler generates dot class file for every class and every interface in a source file. For every class, dot class generated. Every interface, dot class generated. Interface also on dot class file generated. Now, is it over? Here, one more concept. Class A, class B. Which keyword will write to inherit? Extends. Interface A, class B. Which keyword will write? Implements. Because interface contains abstract methods. Those all you must override. You must implement. That's what implements. Third one, interface A, another interface B. Which keyword? Extends. Okay. Fourth one, class A, interface B. Here you observe class. It is a class. These class features we are extending with this class. Same. Class. Listen. Class. A class features we are extending with B class. Okay, that's what extends keyword will write. Here, interface contains abstract methods We are overriding here. Nothing but implementation. First, you must implement. Later, remaining if you want, you can add extra. But implements you must override. That's what implements keyword they given. Interface. It contains some abstract method. You are adding some more abstract methods. That means extending. Class interface. Extends when we'll write if both are same. Is it same? No. It is interface. Interface class implements. But class you cannot implement because here overriding not possible here. Here abstract methods only. So it extends also not possible. Implements also not possible. This combination is illegal. It is valid. It is valid. It is valid. But class cannot be inherited in interface. Note. Class cannot be inherited in interface. Class cannot be inherited in interface. Class cannot be inherited in interface. Is it over? Year class extends. Year interface class implements. Year interface extends. Class interface not possible. Class cannot be inherited in interface. So actually, interface definition I given. It is a collection of public static final variables and public abstract methods I given. But later, so many changes came in interface. That is in further sessions I'll cover. Java 8 features, many are there. That is in further session I'll cover. Now, first is it over? Now, note on. Next point, note on. Interfaces are introduced in Java to achieve multiple inheritance. Interfaces are introduced in Java to achieve multiple inheritance. Interfaces are introduced in Java to achieve multiple inheritance. See, with interfaces, multiple inheritance possible. How? I'll explain. You already studied why Java doesn't support multiple inheritance. You studied. Suppose A is the one class, B is the another class, C is the one class. like this. Here also one show method. Here C OB equal to new C. If I call OB dot show, what will happen? Ambiguity. First it will search in C class, not there. It will search in super class. Two super classes are there. Like compiler gets ambiguity in this line. Either A show or B show. Compiler gets ambiguity. This is the reason not possible, I said. But with interfaces possible. Because here abstract method, you must override here, no? You must override. Then it is going to be called. Interface contains only abstract method. You will override. Overridden method is going to be called. Okay, that is the reason possible. But how syntax appears, you observe. Examples. Say class A, class B, interface C, interface D. Now, here A, B, C, D. Here, how many classes are there? Two classes. How many interface? Between these all, any relationship is there? No, all individual. Okay. Now what I'll do, you observe, class demo extends A, comma B. Two classes. A class, A means class, B means class. Two classes I'm inheriting. Is it valid? Is it valid? Are you listening, class? Give me answer. This much time is not required. Is it valid? Now, which are super classes? Which is subclass? A is superclass, B is superclass. Demo is subclass. Is it valid? Okay, diagram I'll give. It is A class, it is B class, it is demo class. Is it valid? But this is only asked. It is multiple inheritance. Is it possible? No. It is not valid. Two classes we cannot inherit in another class. Java does not support multiple inheritance because of ambiguity to call. You studied. So class demo extends A, extends B. A class, B class, two classes you cannot extend. It is not valid. Now, class demo implements C interface and D interface. It is valid. Two interfaces can be inherited. Two classes cannot be inherited. Class demo extends A class, implements C interface. It is valid. So one class can be inherited, to one interface can be inherited. Like this also valid. Class demo extends A, implements C, comma D. One class, two interface also possible. Interface demo extends C, comma D, also valid. Say here, first A means class, B means class, C means interface, D means interface. Here, demo class extends A class, B class. Two classes cannot be inherited in another class because Java doesn't support multiple inheritance with classes. But C is a interface, D is a interface. Two interfaces can be inherited in class. So it is valid. It is valid. Now, one class, A means class, one interface, one class, one interface, valid. One class, two interfaces, A means class, C and D interface, valid. Two interfaces in another interface, valid. Only thing, two classes not possible. Remaining all valid. Right is all. Multiple inheritance examples like here A means class, B means class, C means interface, D means interface. These four I given. Here I have taken A and B. That means two classes in another interclass. Java doesn't support multiple inheritance with classes, but with interfaces possible. One class, one interface also possible. One class, many interface also possible. Interfaces in interface also possible. Okay. Is it over? Now I'll ask some more questions. Give me answer. Class A. Is it concrete class or abstract class? Is it concrete class or abstract class? Concrete class. This is abstract class or concrete class? Abstract class. Is it concrete interface or abstract interface? Right? Only abstract methods. Can we write here? Can we write? No. third possible. Abstract class possible, interface possible. Which one you'll prefer? Abstract class or
Recording in
method
progress.
references. Constructor references. Stream API. New date and time API. Optional class. New date and time API. Say Java 8. In Java 8, 11 new concepts came. 11 new concepts. In that, majority features interface only. See, it is interface. It is interface. It is interface. It is interface. For this one also interface required. For this one also interface. It is also interface. Interface. These all interface related. So, interface totally changed in Java 8. Many changes came. These features till I didn't cover. I'll cover further. Okay. Just if you want, you can write these notes. Features. Java 8 features. Later I'll cover. These all I'll teach.